Hi, and welcome to my third video on the normal distribution. And in this video I'll be talking through how to use the tables to work out a value of z when you're given a probability. That is, working the other way around. So in my previous video I showed you how to work out a probability by considering the table, and this time if you're given a probability, how to use the tables to work out what the initial value was, what the value of z actually was. Now I'm going to show you what is called the table of percentage points. Here it is. So it's a much smaller table, as you can see, and along the top you've got some mathematical explanation as to what the letters stand for, but put simply speaking, the value of P as a probability is given to you, and you've got various values there beginning with 0.5, and you've got the corresponding values of Z. So that is, when you're given a probability as a particular value, you can look at what the value of Z actually is. Now, come back to me again, let's just explain exactly what that is all about. So I've just put some notional values there from the table. You can check it if you wish. So the first value you give me is, when the probability is 0.5, z is 0. Well, you can see when z is 0, it is there, but either side of that, the probability could be 0.5. Okay? It's not until you get to this one where you've got to really understand what it's actually, how the table actually works. So we're saying that when z is 1.2816, let's just put that about there, shall we? Okay. What it's saying is the probability is 0.1. Hopefully it's clear to you that we're talking about this side of the line there, because that is 0.5, isn't it? Okay. And because this is a much smaller area, it can't possibly be to the left of that line. And that's what this bit is about. That's what the mathematical explanation was for at the beginning, at the top of the table. It's saying to read the table, look at the probability of z is greater than a given value of z, so capital Z greater than little z. The probability of that is P, means that this value here is the probability that z is greater than 0. This bit here means the probability that z is greater than 1.2816 is 0.1. And this one here, it's saying the probability that z is greater than 1.6449 is 0.05. Okay, so 1.6449, if I just rub this out a little bit, okay, that's going to be somewhere around there. So it's saying to us that, looking up in the table, if that is 1.6449, then the probability of a value being greater than that is 0.05. That's how the table works, okay? So it's important you recognise that these probabilities, this time, is everything towards the right of the line, which kind of makes sense because it's the reverse, okay? The reverse of everything to the left of the line is towards the right of the line, okay? I'm hoping that made some sense too. Now, why did I pick out these values, and why are there so few in this table? Well, it's all about what the percentage values are, really, okay? So this will count as 50%, 10%, 5%. Quite often these percentage values, 10%, 5%, 1%, they're actually quite important. It's about statistical significance, but this is not a video about that, okay? You'll learn more about significance in hypothesis testing, should you study that, okay? Let's have a look at some examples, shall we? Okay, in these examples, I'm going to hopefully show you when to use that table of percentage points and when actually you can use the main table. Okay. This is the first example. So we need to find the value of A such that the probability that Z is less than A is 0.7517. Okay. Now, we can actually use the main table to do that, and I'm going to show you how. Here's the main table. See what I've highlighted there? What you've got to look at is you've got to look in the probability columns, and you've got to find the probability in the given question. In this case, 0.7517. The corresponding value of Z, then, you can just read off. What's the corresponding value of Z? It is 0.68, okay, 0.68. So what that means is, if I just cut back to the board, Z is less than 0.68, the probability of that is 0.7517. And we're done. And we're done. We've found our value of A because it fits. So you can see in that example, we didn't actually need to use the table of percentage points, did we? Okay, let's have another one. So here's my next example then. Find A such that the probability of Z being greater than A is 0.100. Why the 100? Maybe it's just to emphasise that we're dealing with 0.1 exactly. I don't know, but when I see that, I kind of think, well, it could be 0.10056 anyway. It doesn't really matter. That's the question. Right, let's just have a look at that first table again, shall we? So here it is. Now, if you remember, it starts with 0.5 and the probabilities go up to 1. So obviously we're not going to find 0.1. So we'll find the difference between that and 1. We'll try and find 0.9 and see if we can do something with it. Now, the trouble is, there is no exact figure for a probability being 0.9. In fact, the closest I can find is 0.8997. But that's not 0.9 exactly, okay? And that gives me a value of Z is 1.28. Well, I've written that down then, so what that would mean is the probability Z is less than 1.28 equals 0.8997. Therefore, the probability of Z being greater than 1.28 would be the difference between that and 1, which is 0.1003. But that is not 0.100, is it? Okay, so you can see there's a difference. It might do for a pretty good estimation, but I think we can do better. And it's in that instance when we might turn to the percentage points. Okay, let's have a look at the table of percentage points then. So here's our table of percentage points. I'm going to try and find the value when P is 0.1, quite easy to do. And then I'm going to look at the corresponding value of Z. It is 1.2816. Okay, right, back to the board then. I've just written that down. So remember, the table shows you everything towards the right of a particular value of Z. So what we have found is the probability of Z is greater than 1.2816 is 0.1. And since we're after a value of A, such that Z is greater than A, that means we've found it. A is 1.2816. Let's just contrast that with using the main table. Using the main table is close enough really to 2 decimal places, but not to 4 decimal places. And that's really the difference, okay? It depends on what accuracy you want it, okay? If you want it to 4 decimal places or 3 decimal places, the table of percentage points really is the way to go. However, if you only need to say 1 or 2 decimal places, then actually the first table would have done, okay? So 2 slightly different methods of doing it. The more accurate one being this, okay? Right, next example. So here we want to find A such that probability Z is greater than A equals 0.0322. Now, we're not going to find that from the percentage points table, are we? No, because in the percentage points table, it's usually 0.5 or 0.1 or something. 0.0322, try it if you want, but it's not there, is it? Okay. So here's an example where we're going to have to use the main table to do it. But before we do that, another reminder, the main table, the probability runs from 0.5 up to 1, doesn't it? Okay, and here we're after 0.032, so we're not actually going to find that in the main table. So what we're going to look for is the difference between that and 1. Okay, so the difference between that and 1 is 0.9678. So that's the one we're going to look for. We're going to try and find that one in the table, because that one hopefully will be there. Let's have a look then. Okay, look it up in the table then, you can see I've highlighted 0.9678, and that gives us a value of Z is 1.85, doesn't it? So what that means is the probability of Z is less than 1.85 is 0.9678. Remember, that's how to read that table, isn't it? And 1.85, let's just put it in by there. So probability of up to that point is 0.9678, okay? So the 0.0322, where does that come in? So that means that must be that probability there. Remember, if that's 0.9678, everything to the right of it, so it adds up to 1, must be 0.0322. So that means we can write down probability Z is greater than 1.85, and that is 0.0322. And since we're after the value of A, such that Z is greater than A, is this probability, that means we've found it. A must be 1.85, okay? Right, this time we're going to find the value of A such that the probability of Z is less than A is 0.1075. So again, the points table is not helpful. Hopefully you get an idea of when to use the points table and when not to. Okay, when you're given, well, basically when you're given an awkward number like that, okay, when it's to 4 decimal places, you're using the main table, all right? And usually it's done quite in a way so it's easy to find, all right? So anyway, we'll use the main table to try and find that. Only it's got to be between 0.5 and 1 again. So what we're going to do, well, we're going to work out the difference between that and 1. So that would be 0.5 0.8925, and we're going to try and find that somewhere in the table. Okay, so here's our table, and can you see I've highlighted P is 0.8925, found it quite nicely, and that gives us a corresponding value of Z is 1.24. So what that means is then that the probability of Z is less than 1.24 is 0.8925. But we've not actually finished the question, have we? Because we want probability Z is less than A is this, 0.1075. So what actually have we found? Right, let's just have a look. Notice how I'm using these diagrams quite a lot, okay? They do give you a good idea of what's happening. These are extremely good visual aids to show you what is actually happening here. So we found the probability of up to 1.24, and let's just have a look at the shaded area, shall we? That shaded area is the 0.1075. Okay, let's just stop that buzzing. There we go, just touch the light and it kind of, it's happy for a little while. So that's the 0.10. So how are we going to get this then? How are we going to get this? Well, just remember about the symmetry of the curve. Where else do you find a probability of 0.1075? It's on the other side of it, isn't it? Okay, so that is 1.24, so negative 1.24. Okay, we'll look something like this. That's negative 1.24. So let's just put in probability Z and then negative 1.24. The probability of Z being greater than 1.24 will be the same as the probability of Z being less than negative 1.24. So 0.1075. And then that is it. That fits nicely with this. Probability Z is less than A is that. A then must be negative 1.24. And then we're done. Okay. Remember, using the symmetry of the curve is extremely important because obviously without it we would not have been able to work out what a value of A was. Right, I've got one more example coming up for you. Right, last one then. So find the value of A such that probability of Z is less than A is 0.75. That usually means we're going to look at the points table, doesn't it? Let's just have a quick look. And the problem here is we're not finding a value that's helpful to us at all. We can't find 0.75 or 0.25 for that matter. So yeah, the points table is not really helping us. So what do? Well, obviously then, we've got to look at the main table. So let's look at the main table to see if we can find the value that will help us. So here's the main table then. So in the main table, I've highlighted two that come close. Okay, so I've got probability of 0.7486 and a probability of 0.7517. Well, there you go, I've written those down. So what that means is probability Z is less than 0.67 is 0.7486, and probability Z is less than 0.68 is 0.7517. Well, what to do? What to do? Well, we just, in this case, just go for the closest one, to be honest. That is 0.0014 away from 0.75. That is 0.0017 away. So this one's actually closer. So we'll just go for that one, okay? That's the simplest case. Yes, you can be more precise if you wish. You can use some sort of interpolation method to try and get more precise. But honestly, if you're only after 2 decimal places, then 0.67 will do. Hey, if you just need it to 1 decimal place, then obviously 0.7 fits both, okay? What I'm saying to you is sometimes the tables don't actually help you to get an exact answer, okay? Sometimes you just gotta estimate as best as possible, all right? Well, I'm hoping that you found this video useful in terms of how to find value of Z when you're given a percentage, and hopefully I'll see you again soon. Bye bye for now.